Hi, I just uploaded my video from my previous bucket project. I'm now recording this one. I'm not sure when I'm gonna edit it and upload it, but I'm gonna fix my drill press finally. There's a safety switch in here. It's been here for a long while. And here's the one I removed from my drill press. And over here I have a new safety switch, which I ordered from a Chinese web shop. Also this one was related to the project. Here's a copper bar for my vice jaws, which can now go back to the other brass and copper pieces I have. There's the cover for the drill press. The railroad track anvil placeholder, which has a bit of an anvil feel to it. It's a part of a machine member from some kind of printing shop device. I'm not sure what it was. Maybe for bookbinding or something like that. Let's see. I've just put this one in. Thinking about making a phonograph generator. I've been wanting to do it, and I saw these stainless steel balls being offered on a Chinese website. And I thought I had another capacitor in here. Here it is. I'm gonna start working on the drill press. I really need it for something. I'm working on a miter saw project, which I can do to help me on something I will do in the future. First, a word of warning. I had a cable break in my test wires, and I ordered a replacement set, and I was going cheap, so I ordered some Chinese stuff. It does have a CE marking, and it's not even the cheap Chinese export mark, but the contacts inside the housing or the terminals wasn't okay. There was no proper contact, so I put some banana plugs on it. And this is a real bad idea. You don't want this wire to be able to come off easily. It's just held in here with a screw, and when there's enough force on the wire, then it will break free. And you don't want to it because when you're measuring mains power or something like that, 230 volts, and the wire comes out, you can get zapped. And sometimes it's not that bad, but the shock or the reaction to it might be worse. If you're on a stepladder, then you might fall off because of the jolt you get. It's not the voltage which is dangerous in that case, it's the reaction to it. But 230 is still something you don't want through your body. So you don't want to use replaceable plugs on your test leads. But I will use these. I'm only going to measure resistance in a unplugged machine. So I think in this case it's safe. Here are the switches. This one came off my drill press. It made a humming noise. And there were plastic covers on these sides too. The humming noise is coming from the relay in my on-off switch. I have to look into it. I can stop it by just opening the cover, which cuts the power. I'm not sure what caused it, but it really sounded like it was coming from the relay. Maybe it couldn't maintain its activating power. And there was a sticker on here, so I could check, and I ordered the same type. This one is from one of those regular web stores, not from AliExpress. I bought this one at Banggood, I think. It's not sure if it's gonna focus camera. KJD12. I also found this one a while ago at a flea market. It's KJD12 to 14, and this one is suitable for 3-phase, but I only have 1-phase. And it's the same brand, as far as I can tell. This one has a CE marking. And it's not the Chinese export marking. The difference is you have CE marking or Chinese export marking, and they're really not the same. Just Google it, check the difference, and you know what to look for. These kind of switches, they activate themselves. When you press the power button, it makes a circuit, and it activates its own magnet to make the switches switch. And then it holds its power until it's disengaged, or this is only mechanical safety switch, or when the power drops, it also releases itself, which is a safety feature, because you don't want the machine to start back up when you had a power loss, and while it was beyond something under your control, you might be wondering what happened to the machine, and you might be holding something like a lathe chuck. You don't want it to start spinning when someone else puts the circuit breaker back in place. So that's a feature of these safety switches. And I also want to take a look at the wiring of my drill press. I already looked into it a bit, and here's a rough schematic of my drill press. It has 2 windings and 2 capacitors, and only 2 leads come into the motor. It has 2 capacitors. One is a start capacitor, and the other one is operating capacitor. Not sure about the English word for it, but I think it's called something like this. The starting capacitor is tied to a switch, which is a centrifugal switch, which opens when the motor is at speed. When it's turning around fast enough, the switch opens, and this capacitor is not in the circuit anymore. I will show it in a minute. And this one is attached to it constantly through the auxiliary winding, while this is the main winding. And I think as a rule the starting capacitor is larger than the operating capacitor. Right, here's the patient. It's just a regular drill press. I already removed this one. I had it upstairs in my bucket. Just moved it over to this table, and you want to, when you move a drill press, you want to move it by grabbing the base, because the head, it's only got these 2 screws, and it rests on the 2 pins on the column. So if you grab it here, the base might fall out. So don't want that happening. I already opened it up and did some measurements. I'll bring you in a There's some straight metal objects here. I'll just bring them a bit closer. So here's what's underneath the switch. I did take some reference pictures when I removed the switch to see what goes where, but I think it's more fun and interesting to see what goes where and how you might solve this problem if you don't know what goes where. It's a bit hard to film in here. I have a light source very close up, and there isn't really much going on in here. There's two wires attached to the metal head of the drilling machine. This metal, the head or the body, I'm not sure what it's called. Oh, this is not a standard feature. I made a video on this a while ago. So there's 3 cables coming out, one with 2 leads and 2 with 3 leads. Now we'll just find out what goes where. Right, I just pressed the wires in a bit and I checked something. It was a good idea to find out if this one actually did fit. It does, but the cover goes the wrong way, I think. I think it should be in like this, but the plate doesn't match up the holes, and the connection of the relays is different, so I can't just swap out this plate. And this fits in the recess, and this one sits on top of it, so I may need to do some filing to get it to fit in. These screws are a bit short, so I'm not sure if I can tighten it while it's sitting on top of it. Just get the display up. Here are the sets of wires. And now opening the cover. There's a switch in the cover. It's a protection feature. It breaks the power when the cover is open, and I can see a small wire coming from it with only 2 leads, and I only got one of these, and I can just follow the wire in here. The switch is in this state, it's open, now it's closed. So there will be 3 connections on the switch, I think. One is the common connector, one is normally open and one is normally closed. So in the switch it needs to be connected to the normally closed one. And here is the wire coming from it. I can test it, but first I will test the plug to see if there is short circuit, and to be certain it's unplugged. Might be a good thing to start with the plug first. So these are plastic caps and crimped wires. There's a bushing crimped over them. I can just put in the pin. This is a normal connector. The pin fits. So this is in fact the switch. Now it's connecting blue wire. So the wires coming from this one. Let's just get the other one out of the way. These wires, one, the green and yellow one, is it's color for the ground wire. It's connected to the ground. and it has a brown and a blue, which is quite normal. But now it has two brown wires and a ground, because this one is an interrupted switch wire. And if I want to check it, here I have the brown wire, the switched wire, which could be black if you're doing installation in a house in Europe. And this is one of the wires coming from the plug, and this should be the other one. And I hope this is in view. And this is the ground. Wow. Right, so I have identified the wire coming from the switch. Maybe I can show the switch. Just notice the screw in there. It's in a screw and the nut. Let's get the camera in. Right, here's the top view. Just undid the screw, and just for fun, I'll show the connections to the switch. Another screw with a nut. Right, so here is the housing for the safety switch. These are standard, you can order replacement ones. If yours is not working, I'd recommend replacing it. There's a tie wrap here, which sort of acts like a strain relief or tension relief. So here are the contacts, and again I can safely measure because I unplugged the machine. So one of these is the common, and one of these is the switched one. And it's they're labeled. So the blue one is common. Number 3, it says NO, normally open, and the other says normally closed. So this one makes contact until you press the switch, and the normally open one is open until you press the switch. Get this back together and put it back in. And as you can see, checking which wire is which isn't really that difficult. Right, so we identified the the plug, the mains port, and then there's these two connectors. And you can trace the wire, and since there's only one other electric object on here, we know it's going to the motor. And let's pretend I unscrew this on camera. Here are the two main wires and the ground wire, which is also connected to the motor. Which it should be, because there could be a non-conductive substance here. Maybe it's really dirty, or there's some kind of anti-vibration stuff on there. So the motor should be grounded, with the ground mark here. So these wires go into a terminal block, and now we have blue and brown wire coming out. But since it's AC, the color doesn't determine what's on the wire, because the plug can be reversed in the socket. Now, then we have 6 leads in total. The 2 coming into the motor, and then these 2 for the capacitors. And this one is 10 microfarad, and this one is 50. But if you wouldn't have these, you'd have to know where to connect the starter one and the normal operating one. As a reference, this is a 370 watt motor for 230 volts, 1400 RPM and 50 Hertz. So I just numbered these wires and measured the resistance across all the wires, and I noted them all down. Here is a list for reference, but I'll do it just now. I numbered them. Blue one is number 1, brown number 2, no pun intended, blue number 3, black number 4, red number 5, and black number 6. Now let's do some quick measurements. I already know which leads are which, but here I have just a connection detector. This blue one, wire number 3, is connected to number 1. Number 5 is also connected to number 1. Number 6 and number 4 are connected. Now do some resistance measurements across the main wires. This is the main winding. Main winding is 23 ohms. Again, for a reference, here is a picture. That's the main winding. This one, so these are the incoming leads, 2 capacitors. Across both windings is from one input to the capacitors. And since I know number 3 and 5 are connected to number 1. This wire must be number 1, and these points are 3 and 5, or 5 and 3. I have to find out which one is which, if you don't know which capacitor goes where. So measuring this wire, will take lead number 6 or 4, or the other way around, to wire number 2. So this is wire number 6. This is about 30 ohms. A bit more, but there's a bit of resistance in these cables. This is a constant reading of 0.4 ohms. And just double check the connections. Number 4. This is also 30 ohms. Wire number 4 to number 1 is 53 ohms. And the same comes for wire number 6 to wire number 1. It's also 53 ohms, which is what you get when you measure both coils at once. This is the auxiliary coil, which should be a bit higher resistance as the main coil. Let's see, maybe I can show something else. No, that's it. Right, so now we know the main winding, the auxiliary winding, and the resistance thereof, and we have identified point 1, 2, and the locations of 4 or 6 and 3 or 5. Now we need to figure out which connections belong to the starting capacitor and which one belong to the running capacitor. So there's two possibilities. The switch is wired between point number 1 and point number 3 or 5, or the switch is wired between this coil and point number 2 and 4 or 6. The switch is normally closed. It's passing current when the motor is off, and it is opened by a centrifugal force when the rotor is up to speed. So we have to find out which of these wires the switch is connected to. And first I will put my test leads. I will start with point 1 and see if it's between 3 or 5. And if I follow the blue wire through this cable, I can plug one of the leads in the connector here, which is easier because I need an extra hand. Put this one in here, and this is the sound it makes when you're measuring along through a capacitor. I've connected to point number 1 and kind of want to test a normally closed connection, so I'm better off testing regular resistance, which is the same measurement, only the buzzer isn't connected. want to jam it in here, so I've got 2 hands free, or I might just hold it. I'm gonna hold it. So we need to find where the centrifugal switch is. Maybe you haven't noticed, but I already removed the belt. And not sure what happens if you try to run the motor in reverse, but the drill chuck rotates this way. So the belt rotates this way. And I need to know that. And I'm just gonna wind a piece of string across the center pulley. Just wind it over itself so it grips a little bit. And I'm using the center one because it's the smallest, where I can just pull the string without it rubbing on this case. If you need more speed, you can also use the other one, but you have to mind this casing. So now I wrap a wire around it, and I'll connect to number 3. So now it's right. It is connected. It's normally closed. So now I'm going to pull this wire. Just check if it's safe. Then there's no belt on the machine, so there's no spindle running. So nothing happened. But you did hear a click, and the click was the re-engaging of the centrifugal switch. It's when the rotor stopped turning. Oh, this is the wrong way around. Not sure if the switch also works if it's going backwards. I hope so. Some of these motors should be reversible, I think. Or not. I'm doing it wrong again. So the switch didn't open or close between number 1 and number 3. So it's safe to say these are connected without a switch in between. So number 3 is either this wire or this wire. Now measuring across wire 5. And as soon as you heard the click, it made contact again. So I found the switch. The switch is between wire number 1 and number 5. That's this situation here. So points 3, 4, 5, 6 are now identified, and I found out which capacitor is the starting capacitor and which one is the running capacitor. I already knew because they are labeled. The big one is 50 farads. That would be a kind of big capacitor. I mean 50 microfarads. Like this. I'm not sure if there could be a situation where point number 5 is between the number 1 and a lead somewhere here. I don't think so, because you have the leads of the capacitor exposed. So you're measuring here and here. Also could be measuring here and here. So that's figured out. I'm not gonna mess around with the replacement capacitor at the moment. Just because I don't know if I have the proper connections, the terminals, and I'm not gonna break these before I know I can use my drill press, because I do want to use it today. So I can close this up and go back to the front. One small note: you might want to use the short screw, which belongs here, instead of a long one. I'm not sure if this could interfere with the rotor, but just keep track of which screw went where. Right, back to the front. I made a quick drawing of things I've identified. Let's put down this side, it's blue and brown. So they will be the same color over here. I noticed something I'm not certain of, or didn't quite like it. Trying to remove the plastic cover. I'm not sure if there's another holding screw. Or it's just being held up by the wires. And have to work around the camera. Right, the thing I noticed is these wires are connected to the ground or the earth. I'm not sure if this is if I can call this a ground connection or if it should be earth. But they were not connected to each other, which means if there is no connection between if the connection between here and the motor is severed for some reason, then you still lose the earth connection. So I will just put them on each other. Not sure where all the screws went. I mean, if the connection between this eyelet and the screw isn't making proper contact, then there's no ground connection. And this should fix it. So there's proper ground. Just measuring the plug once more. First beep you heard was on the base. That's okay. Now this cover needs to go back on. Might have put the wrong screw in the wrong place, or the right screw at the wrong place. Right, so what I did was make this connection. Now for the switch, there's a little schematic on the rear. 2 wires in, switch. I'll just draw it a bit bigger. Right, here's the schematic for the relay. The relay switch for the diagram. Here's the old one, which was attached like this. Here's the on button, which just presses this contact. Now, yeah, I think this white lever has contacts which connects 1 and 2, 3 and 4. And at the same time it has contacts for these coils. So now there's power on these terminals, and the coil is activated, which can hold the this contact here and overcome the tension of these springs. And now the machine is activated until you press the stop button. Which presses this white object. It should reach it when it's screwed on properly. Which disengages this contact. These connections are severed. The coil is deactivated and all power stops. And like I said, it's important to have a machine not start up again when there was a power loss. It's real dangerous. So here's this schematic, and now one. I have to see how it fits in here, and it's just something like this. Now you can connect it the wrong way around. There is, when you put the power on here, the plug for the wall socket, then this one is activated at all times. And I'm not sure if it's powerful enough to draw the tap in from complete distance or only from when it's contacted. I'm not sure it can activate itself like a proper relay. Don't want to test, don't want to find out. But that's the wrong way to connect it. And I think you can see these wires are on this side. I think you can see the wires are on this side. Which means this is the output side. What you can, with this one which is open, you can easily measure. These two don't have a contact. And these have a resistance, which is the resistance of the coil. So this is the output side. So maybe you can find out how to connect this even if there are no markings or if there's nothing on it. Maybe I'll unscrew this when I've closed the machine up. I've rotated this cover, which is a pure mechanical thing. There is a safety switch feature without this yellow stuff. There are two plastic edges around the green button, and this one is accessible. So this should just work. The release is a bit doesn't really feel like nice moving action. Not sure if I can just replace this old cover, which I can unscrew from the base plate and put it on here to use it. Not sure if I'm gonna do it. I'm not used to pressing this button to turn off the machine. I think it's not good practice, because if you just need it, it should work and it shouldn't get damaged by regular use. Although getting used to using this as a normal stop trains you to press this button, so I'm not sure if you're if you should do it. I think it's not good practice. But here's the wire which leads back to the cover switch with two brown leads. And since this one is live in a neutral wire, but can be plugged in two ways in the wall socket, it won't matter which wire goes where. But we'll make the switch wire number 1, and there's also markings in here, I think. Bit hard to see with the light. This says 1 and 3 on this side. Just measure it, just for fun. This is a new unused switch, and it has 4.85 ohms across these tabs for the relay. And these should not be connected. Also, these should not be connected. Right. Take the switched wire, put it on 1. Take this wire, put it on 2. And while connecting this, make sure the plug is unplugged. And it also shouldn't matter which one goes on here. That's not supposed to happen. They shouldn't come off by themselves. Just giving just tightening these tabs a little bit. Maybe it was the using of the measuring pin inside this connector. Feels like a proper connection. This one was interfering a bit with the unit. I'm not sure where the screws were, which I got from the original switch. There's a real Chinese feel to it. Right, final check. Good. Let's check the ground connection. Alright. This should not make any noise. Neither should this. So now these contacts reach the switch, so nothing. Makes a bit of contact when I press the on button, and now I should measure the combined resistance of the coil and the coil in the switch and the coil from the motor. Right, so this works. And I realized maybe the connections were wrong way around before. It could have been a problem I've been solving. But this one won't go anywhere. I might test it. It will be a short separate video if I do. Right, time to test the drill press. Got a separate switch here. I put in my oversized drill chuck, and now the machine is live, and if I press this, the chuck will move. Because I still have to put the belt back. I may have under tension, not too much, I mean, may have not tensioned my belt properly. I like it that way, so I can just move it by hand without moving the motor. This should move the drill shaft. There's a vibrating noise, and I just noticed something. There's a big bend in my belt, so maybe that needs replacing, or maybe there's a way I can ease this out of it. Not sure. Maybe put it in something hot or something like that. I don't know. I used my drill to drill some parts, and I noticed these edges are a bit sharp. I filed them down and smoothed them out with a bit of sanding paper. Is a spring that can be removed, and you can just unscrew this red button, which also had a sharp edge. And maybe I'll leave this one off, so it's easier to just press the on button. I'm finished. Now I have a functioning drill press again. Hope this was interesting. Thanks for watching, and hope to see you soon.